So here we're given this decimal expression, which is in these exponent form. And we're asked that if this was written as a terminating decimal, meaning as point, something like that, how many non-zero digits will it have? So for example, 1/8 is 0.125. That has 3 non-zero digits, because you can write technically 0 afterwards, but those are zeros. The only non-zero are 3. So we have to do something similar here. And the key idea is, how do we go about doing it without actually computing that number, because it's really large. In fact, I would say 5 to the 7, you should never compute such a large exponent. If it's power of 2, probably, but you could get away with it. But anything larger base, powers of 6, 7, never. So the key is, how do we rewrite this? And what we're going to do is to turn this, the denominator, into powers of 10. So essentially, we're going to do, for example, I can demonstrate it with 8, which is 2 cubed. If I multiply this by 5 cubed over 5 cubed, the denominator becomes 10 to the 3. Now, 5 cubed is 125 divided by 1,000, and then we go 3 places back. Of course, with 1/8, I mean, this is probably not necessary. You can just do the actual division. But we can't really do the division here, so we're going to take that route here. So essentially, I can create 10 to the 7 here if I multiply it, numerator and denominator, by 2 to the 4. This would be 2 to the 4, and then 2 to the 7 times 5 to the 7. This becomes 10 to the 7, and 2 to the 4 is 16. Now, essentially, you're going back 7 places from this point. But we don't really need to do that. We know that the number of non-zero digits are 2, which is answer choice B.